Based on this, what is the conclusion? So all you have to do is take this 4.4 and drop it to see if it falls inside the confidence interval or not. And it doesn't, it falls here, right? 4.4 equals mu naught. So your conclusion, mu is less than 4.4. Because the whole confidence interval is less than 4.4. Get it? I did this one, I did all of these. What is this? Okay, let's go to the beginning of the problem. A local pharmacy wants to investigate the possibility of starting to deliver prescriptions to its senior clients on weekends and decides to conduct a hypothesis test. The owner of the pharmacy has determined that the home delivery idea would be successful if the average time spent on the deliveries does not exceed 38 minutes. He has randomly selected 105 clients and has delivered their prescriptions to their homes. He conducts a hypothesis test and finds the p-value for the test is equal to 0.0742. Please state the correct conclusion. Okay, and here are the questions. Here are the questions. At alpha is equal to 0.03, what does he do? At alpha equals 0.05, what does he do? And so forth. So it's a matter of comparing p and alpha, right? So basically the rule is if p is greater than alpha, do not reject H naught. And if p is less than or equal to alpha, then reject H naught. So what's the right answer? Yep. If alpha is equal to 0.03, then p is greater than alpha. Do not reject H naught. That's the right answer. Everything else is opposite of what it should be. You got it? Okay. Okay, what is the variance of, what is the variance of 3x minus 6y if x and y are independent variables? So it's just once that rule that we wrote on our index card. 9 variance of x plus minus 6 squared variance of y. Right. 9 variance of x, 6 variance of y. That's it. Next one. A test statistic for a certain left-sided hypothesis test is z naught equals 0.40. It's a left-sided test. At the 10% significance level, which of the following is false? Okay, so let me draw this. Alpha is equal to 0.10, left-sided, and z naught equals positive 0.40. Which of the following is false? There is sufficient evidence to reject the null hypothesis. Is that true or false? There is enough evidence to reject the null. No, it's wrong. So that's the answer because it says which of the following is false. Right? So the conclusion is do not reject H naught. So this one that says there is enough evidence to reject would be a false statement, and that would be the answer. Finished. Everything else is just rubbish. Okay, next question. A random sample of 100 observations is to be drawn from a population with a mean of 40 and a standard deviation of 25. The probability that the sample mean exceeds 44. Find the probability that x bar exceeds 44 is what? How are you going to do this problem? Wake up. How should I do this problem?
44 minus 40 divided by 25.
Yeah, do we want to do this by hand? How about norm CDF? Norm CDF, 44, comma infinity, comma mu, 40, comma sigma over rad n. That's the only trick here, sigma over rad n. So 25 over 10, which is 2.5. Got it? When you can, use the calculator. Okay, we did that, we did that. Okay, next one. Suppose 40% of a herd of cattle is infected with a particular disease. Let Y be the number of cattle without disease. Okay, so probability of no disease is equal to 60% if 40% have disease, right? The distribution of Y, which is the number without disease, is what? First choice, binomial with n equals 5 and p equals 0.6. Yeah, that's the one. Sample of size 5, it says. So that would be it. The distribution, that's the very first choice, is binomial with n equals 5 and p is equal to 0.6. The distribution of no disease cattle. Okay, the next one's another hypothesis test. Let's go there. The average growth of a certain variety of pine tree is 10.1 inches in 3 years. A biologist claims that a new variety will have a greater 3-year growth. Okay, so H naught, mu is equal to 10.1, and HA, mu greater than 10.1. A random sample of 25 of the new variety has an average 3-year growth of 10.6 inches. X bar equals 10.6, and a sample standard deviation of 2. Okay, first question. The appropriate null and alternate hypothesis to test the biologist's claims are what? So I already wrote it. Mu equals 10.1 versus mu greater than 10.1. At the 5% level of significance, the null hypothesis is it rejected or not rejected, and why? That means go do the problem, right? Mm-hmm.
What keyword did they use for you?
Greater than? A biologist claims that the new variety will have a greater 3-year growth. Okay, so basically they want to know, are you going to reject or do not reject, and why? So can we go do this problem?
Mm-hmm.
Stat test what? Yeah. Stat test t-test. Data or stats? Yeah, stats. Put that mess in and pick right-sided and tell me what you get for T naught. One point two five. Okay. So I need a critical value, right? 24 degrees of freedom, T24, and it's right-sided, and I don't know if they gave me an alpha, 5% level, 0.05. Can you get me a number, please?
1.711.
1.711, and my test statistic is 1.25. It falls here. So the answer is do not reject. Do not reject H naught. And the p-value will be bigger than alpha. Agree? Look how big that red space is. Okay, it's saying compute the p-value. So, what's the calculator command for the p-value? Of course, I could just take it from my t-test too, but what's the calculator command? Because I can screw you guys by not giving you enough information here, but asking you for the p-value by giving you T naught and the degrees of freedom. So then you'd have to do TCDF, right? So what's the calculator command?
For TCDF.
Yeah, TCDF, left endpoint 1.25, right endpoint infinity, degrees of freedom 24. You see what I'm saying? It's not always stat test t-test, because if I don't give you the S, but I give you the T naught instead, then you would have to go this route. Yeah, and they said, is it between this and that, or that and that, or that and that, all these different choices. So once you get this answer, you can go place the answer in here. All right, so we just finished this page already. Okay, in a survey, 3 out of 4 students said that the courts show too much concern for criminals. 3 out of 4. Find the probability that of 70 randomly selected students, n equals 70, exactly 68 feel that the courts show too much concern. Exactly 68. Go, go, go. How do I do it? Yeah, probability R equals 68 is equal to binomial what?
PDF.
Right. NPR. So 70, comma, 3/4, comma, 68. Part B. At most 56 feel that the courts show too much concern. At most 56. Go.
Binomial CDF.
Well, first like this, right? Okay, binomial CDF. Right. 70, 3/4, 56. Next one. At least 56.
Greater than or equal to.
Probability R greater than or equal to 56. So
1 minus.
binomial CDF, 70, 3/4.
56.
What?
55?
Ah,
Sorry.
55. If I do 56 here, my answer will start at 57, and that's, I don't want that, right?
What did you use again?
55.
No, the other one was at most, this one was.
At least.
Yeah, at least. At least. At most. And if it said more than 55, then you would do this, right? Or at least 56 or more than 55. Okay. Next page. Would 68 be considered unusually high? Would 68 be unusually high? Obviously, it's going to be high because what's the mean of this distribution? Mu equals n times p. So the reason why I'm doing this is because what if it said, would 68 be unusual? Then you would have to see if it's unusually high or unusually low, right? So mu equals n times p. So that's
30.
70 times 3/4. Is it 30?
No,
I don't think
Oh,
so.
shit, my bad. I'm sorry for cursing.
4,
I'm sorry for cursing.
5,
It's
Relax.
52.
I'm sorry.
52.5. Okay, 52.5 is the mean. So because 68 is bigger than 52.5, I'm talking about unusually high, right? High. So, let's see. Is it unusually high? So I want the probability R greater than or equal to 68. You have to go even more than 68 to see what the probability is. So I want 68, 69, and 70. Probability of 68, 69, and 70, which is 1 minus binomial CDF of 70, comma, 3/4, comma, 67. And what is that number? It's 67 because
Yeah.
once I subtract that, I'll be left with. So what do you get?